So inevitably, you're going to get the question, how much is RCX going to cost? How much is it going to save? And I think like most answers in engineering, it really does depend. It depends on the building you're looking at, and until you get out there, you're not going to know for sure what opportunities exist and how much it might save or cost to address those issues. But there are some general rules of thumb that you might hear out there, and that's what we want to talk about in this video. So you might hear things like RCX averages 16% in energy savings. You might hear that it costs about $1 a square foot, or you might hear that it pays back very quickly, typically less than 2 years. So where do these numbers come from? Well, there's a lot of industry sources out there, but I think one of the ones that is most often cited, that really has a wealth of data that we're going to take a look at, is this study from Lawrence Berkeley National Lab. So a few general details about this study, and then we're going to dive into some of the data. So it was a follow-up to a 2004 study done on commissioning. It looks at both new building commissioning as well as existing building commissioning. About 650 different projects for existing building commissioning were reported back and evaluated. And the results are really sliced up in a number of ways that we're going to find pretty meaningful. But before we really get into that, why bother? Why look at these industry studies? And really, first of all, in general, I think looking at these studies is going to help us be able to build justification and communicate that justification for RCX type work. As we're in the benchmarking phase of our studies, it's going to help us to understand what some of the savings potential is with different building types based on these case studies. And in a broader sense, it's really going to help us understand what reasonable expectations may be for different RCX applications. So to access this study, you can go to Lawrence Berkeley National Lab's website. There's a number of different articles and follow-on work that frames this in different ways, but what we're going to do is look at some of the plotted data that I think is really rich and communicates a pretty comprehensive story about RCX. And we're going to flip through that and try to see what we can take away. So one of the first pieces of data in the report is this summary table. So it's got different general information about the study, some of the costs associated with that work, and different types of outcome that came from the RCX performed. So it's actually organized by existing and new buildings. So we look at just the existing buildings and the results that came from that work. We can see a number of interesting things. We see a breakdown of building savings by utility type, which can be very helpful. So what was saved on average for these buildings with electricity demand, gas, central plant, all of the subsystems in that plant. But that 16% that gets cited often is really a median energy savings for all of those projects that were reported back. And then another common number that we see is this payback time. So the median payback being this very low 1.1 years for existing building commissioning. There's also a breakdown in a number of different helpful ways. So first, what we have here is a breakdown by building type. So on the x-axis of this chart, we see the pre-RCX energy efficiency use in terms of source energy. So for different building types, we have the kB2 per square foot at the source, so not the building meter level, but at the utility source point, and then comparing that to the payback time achieved for those building types while they went through existing building commissioning. So the main thing I think to take away here is just that really almost all of these buildings are paying back incredibly quickly for this work. So pretty much everything except that top bubble is under 2 years. So all these bubbles are a different building type. And as you see, the more energy intensive building types, so where you're working with food and cooking, hospitals, lab spaces, the more energy intensive you start, the quicker the payback tended to be. But the size of the bubble here is actually proportional to the energy cost savings associated to that. So the winner here is actually office space. So this office bubble, being the largest, had the highest degree of energy cost savings associated with that work. There's also a breakdown of the cost of that work and comparing that to square footage. So here we see the darker dots is new construction, the lighter dots, the rectangle shape, is existing building commissioning. And here we don't see really strong correlations. We see an overall pattern where the less square footage you're looking at, the more that cost is, but there's really a lot of variation. which is going to suggest that there's more to costing out different type of RCX work than just how big the building is. Depends on the systems you have in there, what the complexity is, and what the skill sets or approaches are that are brought to the table. We also have these results being presented in ranges, which has some meaningful takeaways tied to them. So as we look at the left here, the different energy savings associated with existing building and new commissioning, when we look at just existing building commissioning, we see that 16% median savings, but we also see this at this upper 25 percentile, this number that's kind of at 32, 33%. So what this is really saying is that more than a quarter of the RCX projects in this study had greater than 30% energy savings. So that's a pretty powerful thing, is that even though we had the 16% median savings, a large chunk of these projects in our buildings out there, we can expect this very large energy savings percentage above 30%. And it's almost the opposite story when we look at payback on the right. So for existing buildings, we see this very tight range, which says even though we have that median 1.1 year payback, that really most of the buildings are going to have some rapid payback associated with them. There's also a breakdown of deficiencies. So here we're looking at the quantity of deficiencies and how often those deficiencies were found in different projects, and then broken down by system type. So the one that I would look at first is this thermal distribution. So we see that being found the most often and the most deficiencies with those systems found. So by thermal distribution, what's meant here is the way that load is moved around. So whether in hydronic systems or at the air side, this is really where a lot of the problems were found. So it's one place to focus attention. But really the greater story is that where you have central plants, when you're looking at heating and cooling equipment, and then with your pumping and airside systems, as well as lighting. Those are going to be some of the biggest bang for the bucks that we're going to see based on these results. Things like envelope and plug load, because they're such expansive systems, in a lot of cases we may assume, unless we see major deficiencies, that what you see is what you get, and those may be givens so that we can focus our attention on some of these other systems that have higher instances and degrees of payback. So the deficiencies are also broken down by payback, and the measures used to address those deficiencies have payback numbers tied to them here. So there's a lot to parse through here, but I would just focus attention on the middle part where we're looking at the operations and control category of measures. So where we see the really low payback, we see things that are in many cases associated with our control of the systems. So putting things like set point reset in, different scheduling measures, changing set points, changing how equipment is staged, changing sequences of operations in general, cleaning up our loops, and then addressing things with our occupants. Those are some of the quickest payback measures that were reported back in these studies. There's also some information about why folks are pursuing this in industry, and it's not a huge surprise, but the biggest reason given was to pursue energy savings. So the bigger surprise is the non-energy savings related benefits that were reported back after the RCX work was completed. So we see a lot here that we could talk about, and I think overall this really talks to the force multiplying nature of RCX, that once you go into your buildings, really understand how they're operating and how they can operate better, that's going to have trickle effects into all elements of facility management. But in particular, things to point out is how thermal comfort and IAQ were reported as being improved in these buildings as almost a tangential benefit to the process. But there's also some pretty impressive results about how the maintenance program as a whole improved. So having better instances of equipment life longevity, improving maintenance programs, having these opportunities for training and educating staff. So there's a lot that can emerge from these studies that we may want to keep in mind as we're pursuing or communicating the importance of this work. So another surprise is about how things don't correlate. And one of the examples of that is how there's not really a strong correlation between the costs for these commissioning projects and the savings that resulted here. So we see a lot of data variation here, and what this suggests to me looking at it is that there's more than just what you're paying for or how much of your building is being looked at. So the energy savings is tied to something else, and the study indicates that that's probably tied more to skill set and methodology. And they go on to show this chart. So this will be the last thing we look at. And to me, it's one of the most important things that emerges from that study. And it's linking the detail of your commissioning scope to the energy savings that resulted. And here we really do see a strong correlation. So to me, what this is saying is the more care that goes into how you plan out the steps of your commissioning process, the more savings that you could expect would result. And that's why we're really advocating what others in industry have developed, which is this phased approach to RCX. So treating RCX as a process. And it has phases that start all the way in planning, where you may be looking at things from an organizational level and understanding what buildings to prioritize and how to approach RCX. Planning from the facility level, so looking at things like as-built and utility data to have a more strategic on-site time. When you get on-site in the initial assessment, knowing what to do, what documentation to build, and knowing how to look at your buildings for obvious indicators and map out the different distribution you see and understand how systems are operating and how you may want to look at them in more depth. The more in-depth phase being investigation, actually getting into the data and using things like trends and functional tests to do data analysis and find out how buildings really are operating and how they can operate better. Then you have a implementation and handoff period, and there's right ways to do that based on what you found in the earlier phases. And finally, you could have an ongoing commissioning phase, where either on a continuous basis or at different intervals, you're looking at key parameters and understanding how to notify the right folks when certain results are found, and having a plan to really try to retain those savings and have some resilience or longevity of improved operation. So there's a lot of resources at the back end of the study. There's also a resource database that we maintain where I think we got about 300 different resources organized by reference type, so whether it's a certification program or whether it's a tool, a guide, a set of case studies, how old that is, and where the reference can be found, and what the source is. If there's anything in particular you're looking for, please let me know. But really, I just want to focus as we wrap up here about the two big takeaways. And the first one for me is that the RCX justification is very strong. And one way that we can frame that is with our proverbial tree of low-hanging fruit. So we could probably expect that in recent years of focus on energy management in our buildings, that some of that low-hanging fruit has been plucked. So with things like simple scheduling and improvements in the efficiency of our lighting and HVAC equipment, some of that fruit may not be coming back. So when we put in LED lighting into our buildings, or when we're approaching theoretical limits to how good our HVAC equipment can get, we have very high efficiency condensing boilers. We have very low kW per ton chill water units that are being put into place. So we got to look elsewhere. If we look at the top of the tree, we have things like deep energy retrofits and renewable energy systems. And these may be great approaches that we may want to incorporate, but not every project is going to have that opportunity to get way up there. So what we're left with is this low to medium hanging fruit. And I think we can look at RCX as really part of a strategy of just operating our building well and having enhanced facility management to find that hidden fruit and to be that next generation of energy savings that we need. And then the second takeaway is really just about how to caveat or apply these numbers that come from these industry studies. So we saw these breakdowns about how different building types and different utility mixes and other factors are really going to affect the cost and the savings that we may expect on a general nature. So you may want to tailor your estimates to that specific mix of factors for functionality and size and utility type, and use something like a chart here that can be a little bit more of a strategic use of that industry data. Or you may want to operate on ranges. So when you're scoping a building or you're in the planning process, understanding that we really can't dig down to the specific dollar, you may want to use a range. So understanding that there's a starting point, maybe that's 16% median savings, but more you may find in your data analysis and your on-site assessment processes, you may want to move around that range based on what you're seeing and use this low high-end approach to RCX. But I think we can wrap up this industry look and understand that the savings are out there, We just got to find out how to get to them. And I think that's a good segue for our RCX scoping sections, where we're now going to look at the 3D models that have been built and try to go into a virtual mechanical room, looking at things like plant equipment and central air handling units, and try to find some of those techniques to look at these hidden savings and really understand what our buildings are doing before we get on site for the practicum in September. So with that, I'll wrap it up, and we'll see you for the RCX scoping sections.